Hello, my name is Dr. Di Morgan and I work at the University of Cambridge as the Deputy Director for the MPhil in Engineering for Sustainable Development. I also conduct research with the Centre for Sustainable Development and the Centre for Industrial Sustainability, and I study manufacturing and how we can make it more sustainable. And today I'm interested in talking to you about what we are learning from what we observe in two industrial case studies about integrated design process and how organisations can start to bring sustainability into their processes. And I'm going to use a framework to talk about that today. It's a way of thinking about the integrated design process. It's not the only model for thinking about it. It's just helpful for illustrating some of the key points from these case studies. So when we talk about an integrated design process, I like to talk about what the purpose of that process. What are we actually trying to achieve through it? And that allows us to think about what process might be appropriate for trying to deliver to that purpose and which participants need to be involved in order to deliver the end goal. So it's a three-part way of thinking about what are you trying to achieve, how can you try and deliver it, and who should you involve in the process. So that's the starting point, and I'm going to present two case studies. One on a firm that's under pressure from economic and environmental dimensions to change the way they do business in order to become more sustainable in the long term, and another company that sees problems with the way we conduct personal transport at the moment, and I've created a startup from a blank sheet of paper to try and address those issues. So I'll start with the case study called AB Sugar, which is a company based in the UK. Normally we focus on delivering the right quality and cost in a timely fashion. We try and integrate functions and disciplines and pay attention to the timing and intensity of communication when we're delivering products and processes. And we think about all the technical disciplines that need to be in the room. So I'm going to present these two case studies now and sort of build on that process. So this is how we do things today, and I'm going to learn from these two case studies and look at what might sustainable integrated design processes look like and what might they include on these three dimensions. So starting with AB Sugar Wissington, they convert sugar beet, which is this vegetable here, into sugar. They're the leading supplier of UK sugar to the UK market, and they're the only processor of the UK beet crop. They operate in Wissington, which is 20 or 30 miles north of Cambridge, where we're based. They've been operating at this site for over 85 years, and they're the largest beet factory in the world, employing a number of local people, 270 permanent with 500 in the peak season of the sugar beet crop harvest. So they have some challenges. Their site has huge capital investment in it, so they need to sweat those assets and make them as productive as possible. There are lots of local jobs resting on the continuity of production in the factory, and because of these factors, they're vulnerable to changes in cost structure, with the European markets for sugar providing subsidies and quotas, which may change over time. They're vulnerable to changes in climate because they're an agricultural business, and there's risk of the soils degrading over time. And farmers can produce anything they want. They don't have to grow beet sugars. So there's a challenge for the business in terms of how to remain profitable and secure the supply of an essential and irreplaceable raw material. The factory can't move. They can't easily convert to producing something different. So this is a long-term challenge to the sustainability of the company if any of these factors change. So one of their solutions is to diversify their product range. They have their core business of sugar, but in terms of weight, they actually produce more co-products now. So they produce animal feed, they sell lime, they produce bioethanol, all as byproducts of their core process, which I'll introduce now. So you can see here on this image that sugar beet is coming into the top. This is delivered from the local region by trucks from farmers. The material is weighed and sampled, so they take a reading of how much sugar is in the product, and that's what they base their payments on. They unload and clean it, and then they cut it into small French fry-like pieces before they pass it through a diffuser which starts to extract the sugar. This is where the limestone comes in. So then you have a juice, a thin juice, which passes through to an evaporator where they put heat into the process and create a thick juice. So they take some of the water out of it, and then they turn that thick juice into crystals, store it, and turn it into bags, which create sugar. Now, for a long time, they've been taking some of the byproducts, like the topsoil, and that is washed off the beet when it comes in off the farm, and selling that. Any stones that are mixed in are graded and turned into aggregate, which is also sold. They take the leftover from the sugar extraction process, the pulp of the beet, and turn that into animal feed. And they also have the leftover lime, which is the byproduct of the purification process, and they sell that back to farmers to put on their land as fertilizer. But subject to these increasing economic pressures and potential changes in the market, they sought to diversify their operation and make themselves more independent. They created brought in a combined heat and power plant which generates electricity but also provides heat from their process, giving them some independence from the national energy grid. But this also produces waste heat, which is of a low grade, but which they've decided to use to help enhance the growth of more agricultural products. They are now the biggest specialty tomato producer in the UK, combining waste heat from their process and waste CO2 from the combined heat and power plant, both of which enhance the growth of tomatoes and allow them to be more productive over the same land area. They also, to cope with the quotas that have been imposed on them, sometimes they take the thick juice that they've produced, and rather than turn that into sugar product, they turn it into bioethanol. So they ferment the sugar and create a bioethanol product, which they sell into a different market. There is also a byproduct of that process, which is CO2, which they've invited a company in to take the CO2 from that process and have a contract with them now. So all of a sudden, you've gone from being a sugar factory to being almost a biorefinery, as they describe themselves. So they sell electricity, tomatoes, liquid CO2, bioethanol, and a number of other chemical byproducts that emerge from the process, which they add value to. So nothing leaves the site without value having been added to it. A really unique and interesting story. So this is a view of the tomatoes in the greenhouse. Something to note is that now that they've started to identify opportunities to make use of underutilized resources or to reuse waste, they harvest rainwater from the roof of the greenhouse in order to feed the tomatoes. You can see these rail tracks here. These are the rail tracks which the pickers slide up and down in order to harvest the fruit, but they're also the pipes which carry the heat from the waste heat from the process in. So they're using multifunctional approach. Rather than having two systems, they use one system to deliver two functions. And it's become a very serious part of their business. This is one of my colleagues who's been invited to join one of their tasting sessions to make sure they have the best quality varieties of tomato. So they've become serious horticulturalists as well as their core process. And now co-products are actually thought to be responsible for most of their growth in revenues and represent around a quarter of their total revenues overall. And they're continuing to seek to extract more value from the resources that they now have. Now they're looking at the greenhouse and thinking, what else can we grow in there? And they're actually moving towards growing a version of the cannabis plant which is specifically bred for medical purposes. It can be used in the drugs which are given to children with a rare form of epilepsy. So they're trying to extract even more value from the waste resources that they have. In order to do this, they need to work with other people. They don't always have the capability in order to deliver this. So when they first grew tomatoes, their chemical engineers found they were growing very large, very tasteless tomatoes. So they brought in people who could help them with the horticulture and started a business based on that. The CO2 bottling, they don't do anything to do with that. They bring another company in on contract and provide them access to the CO2. The bioethanol is a collaboration between BP, DuPont, and also involved the UK government to make sure there was going to be a market for the bioethanol coming out. So you now see that AB Foods, which is the overall group, and AB Sugar have a complex ecosystem of wholly owned companies, joint ventures and collaborations which enable them to access the value of this particular model. One of the things that they've had to do in order to develop this was to develop a new team within the organisation to identify these opportunities and to try and infiltrate the new industry to understand how best to interact with them, whether to collaborate, whether to do a joint venture, or whether to develop the capability themselves. So this is one of the underlying capabilities which has enabled the system as it's demonstrated. And one of the things that they've done is work with their suppliers. So they've created a long-term partnership via the National Farmers Union to create the British Beet Research Organisation, which underpins the science of how you grow beet more effectively. And this is embodied in the way that when they sample the beet on the way into the factory, they also feed back the composition of the beet in terms of the nitrogen and phosphor content, so that the farmers can start to plan the next yield and be more precise with how they bring their nutrients onto the land. And this has, over the long term, seen growth in the productivity of sugar beet against other crops. So they're helping it make it worthwhile for the farmers to continue to grow beet and thereby securing their supply. But they're also doing things which make it cheaper for the farmer to do this. So that you have to spend less on protection, less on nitrogen and less on phosphorus because of the work that they've been doing through the joint venture. And they've actually managed to, because of the productivity increases, they've released more land that farmers can use to grow other things. So a really neat collaboration. So going back to our model, we've seen an iterative process of seeking opportunities and moving beyond the traditional boundaries of the business. And they've done this by working with key stakeholders and engaging new and unusual partners to facilitate the novel business lines. And this has really transformed their sense of purpose. They've gone from being a sugar factory to thinking of themselves as a company that has a capability to develop biorefineries where you're extracting the maximum value from the available resources. And they now use sustainability thinking as an innovation lens to try and identify and drive new opportunities. So that's one firm that's been responding to sustainability pressures. The next firm I'm going to talk about has a distinct vision about how they want to change the way we think of automotive transport. And they're driven by a purpose, not to make money, but to pursue systematically the elimination of the environmental impact of personal transport. So they're not coming with any technology prejudices. They're starting with a very open idea of delivering an outcome. Personal transport without environmental impact. And of course, they've had to develop some very smart technology in order to do this. This is a diagrammatic representation of the vehicle, and you can see here that each wheel is driven by a single motor, so they're not connected like a regular car. Each motor works independently, but is connected via a network to the fuel cell, which handles the cruising function. So when you get up to 60 miles an hour and you just want to pootle along, that will take care of that. And they have ultracapacitors for the high energy density demand storage. So when you want to accelerate, then this is where the power comes from. But it also is used in regenerative braking. So when the car is braking, it passes energy into the ultracapacitors to store ready for deployment on acceleration. So they also are looking at how they're designing their business model though. So much like a mobile phone, they're going to charge you for access to the car and analogous to sort of access to the phone, and also selling the miles traveled as a service. So they will put the fuel into the car in the same way that we get charged for the minutes we use on a phone. So they sell miles travelled as a service and access to the car. That incentivizes them to make the car as fuel efficient as possible and to maximize the longevity of the car and avoid obsolescence, so they can make money from multiple customers as they go along. So they get access to revenues generated in the second-hand market, which aren't accessible to companies who just sell you a car as a one-off purchase. So an interesting model. It's not just about the product design, it's about the business model that goes with it. And they think about the whole system of how the business will be organized, from the infrastructure that will support the car. They're looking at a city-by-city service so that they only have to develop the hydrogen infrastructure for a single city. They think about the supply chain and making sure that the ownership model flows back into the supply chain, because they'll be the company that develops the motors will be the best company to make to understand how to recycle it and use it at the end of life. So it's a whole system view. It's not just designing any one component, it's trying to think of how it all fits together. The other thing that they do, talking about environmental, social and economic dimensions, is make sure that the stakeholders who might be impacted or benefited by the business have an equal say in how the business is run. So they have stewards who advise and hold to account the board, and those stewards are representatives of the environment. So there's an environmental representative, the users, the neighbours, the people who are directly impacted by the operation of the business, the staff, the investors, and the commercial partners. And these all have a say in the direction that the board is given, and therefore how the company is run. So it's rather than trying to optimise for economic benefit, they're trying to optimise for the benefit of all these different stakeholders. So a very different model from how most companies are run. So the end result, and this is still in the startup stage, this is what the car looks like. They've just closed their latest crowdfunding round and have raised around £1 million to match European money. And the car runs at 1 litre per 100 kilometres equivalent, and that's taking a brown hydrogen cycle. So if it used green hydrogen, it would perform even better. To give you some sense of scale, one of the later models of the Toyota Prius runs at 3.9 litres per 100 kilometres. So it uses much more fuel to deliver the same service. It's roughly the same cost to the customer as a smart car, so relatively cheap to run, and is worth more over the lifetime of the vehicle to investors, so represents a potential investment opportunity. So on this design process, the purpose is explicitly seeking positive benefits on multiple dimensions. They've gone through an iterative process with considering multiple variables at the same time, rather than just considering one set of variables, or such as product design or business model. They're considering them all at the same time. And they're directly involving the stakeholders in the governance of the business to make sure that there's a balance between the environmental, social and economic dimensions of the firm. And they're directly involving users in providing testing and feedback. The crowdfunding that they've just raised will be used to pay for 20 cars for consumers to go out and beta test in Monmouthshire. So they'll get direct feedback from the consumer as to what the next iteration of the product and the business should look like. So to conclude, what might an integrated design process for sustainability have as part of it? Well, in terms of purpose, it's really explicitly seeking multiple positive benefits simultaneously along ecological, social and economic dimensions. It's using transdisciplinary teams coming together across the whole of the business and beyond to develop ideas and to directly involve stakeholders in the design process throughout the life cycle. And finally, it's using an iterative process, much like the sugar business, built slowly rather than design straight the whole system. It's an iterative process where all the variables are considered concurrently and feedbacks are built into the process throughout. So that's a very brief overview of some of the trends we're seeing in integrated design processes. I hope you found it interesting, and I look forward to seeing the integrated design processes and outcomes that you go on to deliver for sustainability. Thank you. Muchas gracias.